which was not necessarily the greatest idea either because of what the astronauts referred to as the BFRC, which stands for Big Something Red Cloud. The BFRC was what was generated by the Titan missile. Once again, this is a military vehicle. This thing is an intercontinental ballistic missile designed to fire from silos with very little prep time and launch nuclear warheads to the other side of the planet. It was modified for use in Project Gemini. One of the things that made it silo launchable was they came up with an entirely different ignition system than most other rockets used. They used hypergolic fuels. Everyone know what hypergolic refers to? The idea there is instead of having lots of sparks and arcs and other stuff when you combine your oxygen and hydrogen or oxygen and alcohol or whatever you're actually using in your first stage, what happened here is this vehicle had two tanks, each containing highly volatile, relatively stable chemicals until you put them together. Nitrogen text oxide and something else equally horrible, which I can't remember offhand, but once again, it's because I'm old. These would come together in the bell, in the actual launch chamber itself, and they ignited on contact. Really, all you had to do with this vehicle was open valves. It was the same approach that was used for the lunar vehicle, the Apollo craft that had to fire its engine to come back from the moon also used hypergolics because it was very, very simple. It was very basic. The shuttle used, I guess that's the appropriate word now, hypergolic fuels for its maneuvering engines. And in fact, if you watch the shuttle land, you'll notice that the astronauts have to stay inside for often up to 2 or 3 hours before they're actually allowed to egress. The reason is they have to drain the hypergolic fuels. They are incredibly toxic. They have a tendency to melt flesh and anything else on contact. And also, if you mix them together, bad things happen, unless you intend those bad things to happen. So one of the consequences was, when the Titan engines would fire, this enormous amount of fantastically acidic, toxic, horrible cloud would engulf the entire launch platform. It is not the place that you want to have a problem and eject seats right into. So the astronauts were not crazy about that. They referred to the protocol of ejecting from Titan as committing suicide to keep from getting killed. And with that in mind, let me show you a clip. What you'll see here are actually 2 different pieces in a row. This is Scott Crossfield, once again talking about the Regala wing approach that he was in charge of developing and why it didn't work out so well. And you will also see Wally Schirra, the only astronaut to fly in Mercury, Gemini, and Apollo, having a rather bad day at launch aboard Gemini.
4 times the weight of Mercury, the Gemini spacecraft would need something more than an Atlas booster to get it into orbit. The largest missile in the nuclear stockpile was the 9-story, 2-stage Titan II. Capable of lobbing a 3-ton warhead pretty much anywhere on the planet, it was more than up to the task.
Riding the Gemini at the end of a Titan, it was like, imagine somebody riding a warhead would be like. I mean, when it got to the proper speed and altitude, you were just pulling 8 Gs and it went from 8 Gs to 0 right there, bang, and all of a sudden, all the washers and stuff that the workmen left of the spacecraft suddenly floated up.
One of the most noticeable differences between Mercury and Gemini was the lack of an emergency escape tower. Gemini was going to avoid the indignities of splashdown and glide in to land on hard tarmac. This lateral flight through the atmosphere called for fighter jet style ejection seats, making the escape tower redundant. The returning Gemini would deploy a Regala wing, an expandable parasail that would turn the spacecraft into a glider. It was an idea decades ahead of its time, and nobody quite knew just how to make it work.
an inflatable wing, 3 inflatable tubes that made a 60-degree delta wing that they thought would be useful to inflate, return from orbit, and bring the Gemini home. It's a lousy idea. We got the contract at North American to do that, and it got into all kinds of problems. The people within the company were totally frustrated, NASA was totally frustrated, and it just wasn't going to go anywhere. Actually, I pulled 2 pilots back from and finally decided I wasn't going to ask any of my pilots to fly it anymore. I was going to fly it. Stormy wouldn't let me.
Although the Regala wing never worked on Gemini, it would serve as the inspiration for a very popular sport. The failure of the Regala wing meant that Gemini would splash down in the ocean like Mercury before it. But it was too late to fit a Mercury-style launch escape tower. The ejection seats would be the only way out in case of a launch pad disaster. The astronaut described the protocol as committing suicide to keep from being killed.
By pulling a lever between our legs. But when you really analyze, say, a fire on the launch pad and this big rocket collapsing and the fuel that was very toxic, fuel that had very toxic fumes, and those ejection seats would go out, I often wondered whether we would ever clear the cloud, the toxic cloud, to land safely. But fortunately, we never had to use the ejection seat. And the only other thing I worried about was to make sure I could safe that lanyard once I get into space, because I sure didn't want to pull that ejection seat out into orbit.
5, 4, 3, 2, 1. Ignition. Shutdown, Gemini 6.
The rocket engines of Gemini 6 ignite, then immediately shut down. An automatic abort command has halted the launch. No one knows why, and no one knows what to do next.
Okay, we just did a little reading. We knew that something had happened, of course. We knew we had not lifted off. Now they're getting interested because we had conversation. The clock's still running. How you doing? We're sitting up here just breathing. They thought we said breeding or something. I couldn't believe it. Okay, we just did a little reading.
If the rocket explodes with the astronauts on board, they'll be killed. If they eject, they could die in the cloud of deadly fuel. Schirra grasps the jettison ring. There's only one right choice, but which is it?
Schirra and Stafford basically decided that they were not going to eject, okay? And they held their fire at the same time. I have a controller in mission control who had similar responsibilities. He had his finger on the abort switch, and he also decided to hold fire. So this was probably one of the most short-term, riskiest, and 100% correct decisions that we had ever made.
They did the right thing there, absolutely, because I think they saved not only the program at that point in time, they saved themselves, stayed on the pad, and it allowed us to keep the program going.
The problem was traced to a small cover accidentally left in place over an engine intake. With crew and rocket still intact, NASA could try again. 3 days later, it all went just right.